All right, so we're going to be rotating these about different axes now. So we're going to use the y equals 2 line to rotate this. And so if I rotate it around the y equals 2, it's just like rotating around the x. In order to get that washer, I need to have a vertical rectangle so that when I rotate it, it creates my washer. So now all I need to do is find those radii, and it's not as easy, but it's not difficult as well. So if I do pi big R squared minus little r squared, because I do have a washer, and I draw my washer, let's start with the big one first. So right now this is not 0, this is at 2, right? So if I were to plug in a number into here, into my rectangle, it goes all the way up to here. But I don't want to go all the way up to there because that would give me this massive circle. So all I'm going to do is go from here to here. That is my big radius. So what that means is it means I have to do some subtracting. So for my big circle, it would be, for my big R, it's going to be my function itself, which is 4 minus x squared. But then I have to take away the 2 part. This part right here needs to be removed. Otherwise I get the full gigantic one. So on each of these, when you have an axis of rotation, all you do is subtract that part that's needed. And then it works the same thing with the inner guy. So my little tiny radius here, that one is a radius of 3. So it would be 3 take away 2. And that one's a lot easier to see. You can actually see that we have 3 and we have 2. And so that radius of that little inner circle is 3 take away 2, which is 1. It's constant. So now that we have these, we need to make sure everything is set up. So I haven't labeled my rectangle yet. That is going to be dx, and that's going to be y equals. So I need to go over here and make sure everything says y equals, and we're good. Now we need to plug our radiuses in to find our area. So this would become 4 take away x squared minus 2. That's 2 minus x squared. And that one's 1. So 2 minus x squared squared minus 1 squared. And so now we have our integral. So it's pi 2 minus x squared squared minus 1 squared. dx is the thickness again of it. So that's giving us our volume. Now we need our start to finish. So it looks like it's from -1 to 1. But again, we need to verify that this is correct. So we need to set them equal and then solve. So yes, it is. X equals -1 and 1. And wherever you're placing them between your dx, so we know for our dx it's going to go from -1 to 1. Because again, we're just going to slide this rectangle over from left to right. So going from -1 to 1. And there we have it. Now we just have to plug that in our calculator to get an answer. So we end up with 56 over 15 pi. Now on each of these, you're basically either going to be adding or subtracting them based on how they look and where they're at. So if this axis is way down here below, then we'd actually have to add the 2 because our rotation would be a lot larger. So you just have to look at the picture to verify whether you're adding it or subtracting it. So let's try our next one where we get to add it. So on this one, we're going to be rotating it around the x equals -2 line. Right there. Okay, so if we end up having that, we know that we need to have our rectangle this way. So that would make it a dy and an x equals. So everything over here needs to be solved for x. And the reason we're using the positive square root of y is because we are using y equals x squared on the positive side. And so that would give us this one, not the -1, which is actually, yeah, right there. Okay, so now let's rotate it. And let's just do the inner one first. So again, we're going to go to 2 past and a little bit more. And so if we can find the inner radius first, then it makes things a lot easier. So if you notice, from here to here is 2. And then from here to here is our inner function right here, which would be the, right here, the x equals y squared one. So y squared. Again, everything needs to be x equals. So that's our y squared. And then that is our y equals x squared, or our square root of y. That's our parabola. All right. So our inner circle, I'm going to make it a little bit smaller, is going to be 2 plus that. So that's our inner radius. And so you can still see we're subtracting it. If you subtract a -2, it becomes +2. Correct. Now let's do the outer one. And we'll do that one in blue, just like the other one. So if we trace that around, you can see it's the same idea. So this outer function is the square root of y. And so what we're getting is 2 plus the square root of y, because from here to here is our square root of y. So from there to there is square root of y plus 2. So it's the same idea. It's just square root of y. Take away -2. That makes it +2. So our outer one is going to have a radius of the square root of y plus 2. And so now we have our radii. We can now write our formula. So it's pi, big R squared, which would be the y plus 2, square root of y plus 2 squared, minus the little one, which is 2 plus x squared, y squared, square root of y, squared, why did I put an x in there? So it gets a little confusing, so you just have to make sure that you catch yourself. That's a y squared because everything is x equals. You can see it over here. The y squared is the inner one. I just made it look like an x. The outer one is the square root of y. So 2 plus y squared. And there's our area. I didn't square it. There we go. So now we just need the values that we're going from start to finish. So if we set these equal to each other, and solve them, we get y, we're going to square both sides, so 4th to the y, and so y to the 4th minus 1 equals 0, and then that would become y cubed minus 1 equals 0, so we get y equals 0 and y equals 1, which is what we had, 0 and 1. Remember, your dy will always be the one that's in between those two numbers, so it's 0 to 1, dy, pi, square root of y plus 2 squared, minus 2 plus y squared, and then we plug this in our calculator. And so we end up with 5.13 for our answer.